Alrighty, so should be all good here. Yep. Here is an example of our Pascal triangles. This is what we are currently learning. Let me delete that. So we have an example problem here. We have 4x plus 5 to the 7th power. Of course, this is a binomial, so we have our binomial, and now we are going to take it to the 7th power. So here I have our Pascal triangle laid out. What we are doing is adding this previous value. So 1 plus 0 is 1, 1 plus 0 is 1. We started off, ended off with 1. Here, now what we do, 1 plus 1 is 2, and then 1, 1. So with Pascal's triangle, every single sequence will start with 1 and end with 1. And what we're doing is adding these two numbers together. Let me delete all of these. I thought it would make it easier, but no, it's still pretty difficult. So let me hide that really quick. Sorry about that. Bum, 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 bum. Bum, bum. Bum, bum, bum. Okay. That should make everything easier. So here, Pascal's triangle. 1 plus 0, 1, 1 plus 0, 1. Starts and ends with 1. Starts and ends with 1. 1 plus 1, 2. Now we start getting into adding up the other numbers. So 1, 1, 1 plus 2 is 3, 2 plus 1 is 3, 1, 1. And then the pattern repeats. Starts with 1, ends with 1, but now we do 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. Then for 5th power, we get 1. 1 plus 4 is 5, 4 plus 6, 10, 6 plus 4, 10, 4 plus 1, 5, 1, 1. Now we get 1. 1 plus 5, 6, 5 plus 10, 15, 10 plus 10, 20, 5 plus 10 plus 5, 15, 5 plus 1, 6, 1. And finally, for the 7th power, we get 1 plus 6, 7, 6 plus 15, 21, 15 plus 20, 35, 20 plus 15, 35, 15 plus 6, 21, and 6 plus 1, 7. And of course, we started off with 1 and always end off with 1. So here, I've laid out kind of like how Miss Watkins sets hers up. Let me clean it up just a teensy bit to make it look a little bit more appealing. My bad about that. Zoom in plus. Alrighty, so our values will be 4x plus 5 to the 7th power. So if we look to our Pascal's triangle, for value 7, we have 1, 2, 3, 4, 5, 6, 7, 8 terms. So when we do the equation right out, it'll be 1, 2, 3, 4, 5, 6, 7, 8 terms. Now for here, this 5 will always stay a 5. This is our constant in this case. So this will be, I think, 5x7, 5x6, 5x5, 4x to the 7th, 4x to the 6th, 4x to the 5th, 4x to the 1st, 4x to the 4th, I believe. Yeah, 4x to the 3rd, 4x to the 2nd, 4x to the 1st, and then this is our constant. So as we go across, we start at 0 from this 5 to the 0th power, because this is our first term. 5 to the 1st is our second term. 2. So every single time you go down a term, it increases the power by 1. So it increases a by 1. So let's see. We'll do 5, and then this will be a, and this will be 4x to the power of, I don't know, let's call this p. So as p decreases, as our terms decrease, a will increase. So as p decreases, a increases. So 5 to the third, 5 to the fourth, fifth, sixth, and finally seventh. Now what we're going to do here is we have our 4x. So we will outline our 4x right here. And we put that in parentheses, and then we put the power on. So this is term number 1. So we'll start off with the 7, which is this power here. Start off with 7. Then we work our way down. 4x to the 6th. Sorry. 4x to the 6th. 4x to the 5th. 4x to the 4th. 4x to the 3rd. 4x to the 2nd. 4x to the 1st, and finally 4x to the 0 or 0. Now we have our basic outline set up. We start off with this 7. We have our 5 to the 0 power, and now our Pascal triangle comes into play. All of these values we will plug in front of every single term. So this will be 1. This will be 7. I didn't give myself enough room here. Let me. That's what I like about online whiteboards. I can shift this all around. No, yeah, I need to give myself tons more room. All right, let me shift my Pascal's triangle really quickly. Shift it. Shift it. Sorry about the delay. Shift it down a little more. It's gonna take a few, sorry. And I'm also sorry if my mouse is too loud. It's the easiest way for me to do all this equation stuff. Alright, so now we are finally set up. Now what we are doing is taking this previous value of the Pascal triangle, so we'll cap off both ends with 1. Now we start inputting these values. So 1, 7, now 21, 35, 35, 21, 7, and 1. So now what we'll do here is we use our calculators to finally set everything up. I have the same kind of calculator that Miss Boykins has. So I turn it on, I will clear everything out. Now I will do 5 to the 0th power, so 5 to the power of 0, which provides us with 1. And then 4x to the 7th, so we will do 4 to the 7th power, which gives us 16,384. Times that by 1. We get, well, we multiply by that one and multiply by the other one, which still gives us 1,603. 16,384 is our current answer. So now what we can do is since we know we have x to the 7th, we get 16,384 to x to the 7th power. Hope that makes sense. Now we will do this problem. We put into our calculator 5 to the 1st power, which gives us 5, and then 4 to the 6th power, which provides us with 4,096. We multiply that by 5, and then multiply that by 7, which gives us a total of 143,360 x to the 6th power. So 1, 4, 3, 3, 6, 0, x 6. Now this does take a bit of getting used to because these are huge numbers, but after a while it becomes easier. So we'll do 4 to the 5th, 1024, 5 to the 2nd. So 1024 times 25 times 21. We get an answer of 537,600. 537,600. And of course, I'll double check the work after just to make sure I'm not misleading you. Now we are on to term number 4, which we do 5 to the 3rd power, 125. 4 to the 4th power times 125, we get 32,000, and now we multiply that by 25. Not 25, sorry, 35. We get a big number here, 1,120,000. So 1, 1, 2, 0, 1, 2, 3, x. I think this is a bad example on my part, so an x to the 4th. Now, let me pull up Pascal triangle calculator. We will quickly put in show rows. It's not what I was intending. I use Microsoft a lot to pull this out. It will be 4x plus 5 to the 7th power. Let's see if I could. 4x plus 5 to the 7th. I hope it solves it. Or I'm just going to look really dumb here because I hope it didn't mess up. I'm doing it the way Miss Blakens was showing us earlier. So let's hope. Sorry if my thing is taking too long. Okay, I'm still doing decently. Yeah, everything looks good so far. Let's compare answers very quickly. 16,384x, 7, 143,000. Something. Looks like all the answers are lining up. So that I can complete the example, but I can leave it off here, which I think would be better. So I will give you a practice problem, something slightly easier, because these are big numbers. So the practice problem I will give to you will be 3x plus 2. And we'll do that to the fourth power. Sorry. So go ahead and complete that using the Pascal triangle. So I will write it out. 1, 2, 3, and 4. This will be 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. That is your Pascal triangle, and this is your problem. Go ahead and try it out. And I'm glad I could help.